So good morning, welcome to my channel. My today's topic is matrix multiplication, how to multiply two matrices. Okay, so suppose first of all I am taking two matrices, one A, okay, one is A11, A12, A13, A21, A22, A23. There are some few generalized rules is there, so if you can remember the rules you can understand better. Okay, so first of all it is how many the order means how many rows, two rows and three columns, so it is 2 cross 3 matrix. Okay, it is 2 cross 3 matrix. So in this way actually, and the next one, suppose I am in general I am writing here, in general I am writing here m1 cross n1. Okay, m1 cross n1. This is the first case. Second case, B is another matrix B11, B12, B13, B21, B22, B23, B31, B32, B33. Suppose I am taking another matrix whose order is, it is M1, N1. M1 means the rows, number of rows of first matrix, number of columns of first matrix. N1 means here M2, N2. Cross M2 cross N2. Okay, the condition means the product condition or multiplication condition is that means you can multiply only when N1 will be equals to M2. Number of the condition is N1 must be equals to M2. Please remember this condition. N1 means number of column in first matrix must be equals to number of rows in second matrix. This is the condition. If this condition will satisfy, then only multiplication possible, otherwise not possible. Please remember, if this number of column and number of rows, here number of column in first matrix must be equals to number of rows in the second matrix, then only multiplication possible, then only multiplication possible. Here what is the order is 2 cross 3, here 2 cross 3. Okay, here how many order? 3 cross 3. 3 cross 3 you can check here, N1 is 3, here M2 is 3, so both are 3, that means multiplication is possible in that case, otherwise it will not be possible. And please remember, after multiplication, suppose C, the value C is coming, C is nothing but A into B or AB, you can say the order of C is nothing but first M1 and last is N2, so order is M1 cross N2. Please remember, order is M1 cross N2. Whenever after getting the products or after getting the multiplication value, the order will be M1 cross N2. So this is the order. So here 2 cross 3 matrix for the first case, this is 3 cross 3 matrix. So after multiplication, the order will be 2 cross 3. Here 2 means first one and the 3 is the last one. So this is the order of the final result. Okay, so this is how multiplication can be done. I will show you some examples so that it can be you can clearly understand. Okay, so first of all, free property, suppose A is a matrix 2 3 1 5 and B is another matrix 1 2 1 3. Okay, now I want to make, this is 2 cross 2 matrix and this is also 2 cross 2 matrix. Now how to multiply two matrices? First write down, so suppose another matrix I want to form by multiplying these two, AB. Okay, C is AB, nothing but A into B. A dot B means A into B. So write down first 2 3 1 5 and 1 2 1 3. Okay, first please listen to me very carefully. The formation is like a 7 formation. 7 formation, do you know this is like a 7? Okay, 7 means it is row, it is column. So just remember how many rows are there, 1 and 2 rows. Here also 1 and 2 rows. How many columns? 1 and 2 columns. This is also 1 and 2 columns. So first row with first column, will be the first element. So there will be how many? This is 2 cross 2 and this is also 2 cross 2. As I told you, the final result will be here first and this is last. So final result will be 2 cross 2 matrix. Final result. Okay, so 2 cross 2 means there will be 4 digit Okay, so first digit will be please remember, first row and first column will be the first digit, first row and second column will be the second digit, second row first column will be the third digit, and second row and second column is the fourth digit, in this way. Okay, so how to remember? So 2 into first row first column I am doing first, so 2 into 1 you have to write in this way, 2 into 1 bracket plus 3 into what is this, 1, 3 into 1. Okay, next, so if I want to make this one, so this row and this column, so 2 into 2, 2 into 2 plus 3 into 3, 3 into 3. Okay, next I want to make this point, 1 into 1, 1 into 1 plus 5 into 1, 5 into 1. Okay, in this way. Similarly 1 into 2, 1 into 2 and 5 into 3 plus 5 into 3. This is the formation. Please remember, I am multiplying this with this and this with this. You cannot multiply this with this. Okay, the first position always with the first position. Okay, so in this way, so ultimate resultant is coming 2 ones are 2 into 1 2, 3 into 1 3, so 3 plus 2 is 5 and 2 to 4, 3 3 9, 9 plus 4 is 13. Okay, 5 1 5 and 1 1 1, so 5 1 6 and 5 3 15 plus 2, that is 17. So this is the C value, means the multiplication, after doing multiplication this is the answer. Okay, so this is how the whole multiplication, matrix multiplication can be done. Is that clear? Now next few properties. Please remember, a commutative property. First is commutative property does not allow in matrix multiplication, means A into B. If you do A into B, suppose two matrices are there, one matrix A is equals to 2 3 1 3, another matrix B equals to 1 2 2 1 3, suppose. Okay, 1 2 1 3. So A dot B and B dot A, if you do A dot B first then B dot A, you can see that this is not equal, so they doesn't allow the commutative property. The commutative property, commutative law does not obey, so does not obey, you can say. Okay, so commutative property does not obey. This is the first case. Second case, but associative property can obey. Associative property tells that A into B with bracket into C equals to A into B into C. This will obey. Suppose another matrix I am taking C. This is suppose 1 1 2 1. Okay, if you multiply in this way, A dot B first, then with that C, and then in this way, this is called associative property. It will follow, but it doesn't follow. Associative property in case of multiplication will follow. And the third one, distributive property, A into B plus C, that means AB plus AC. Okay, you can check from here also. You can check from here, A into A means this matrix, B plus C, first add B plus C, and if you multiply it and individually if you can do left hand side and right hand side, you can see this will follow. So that means this property will follow. This is known as distributive property, distributive law or distributive property. Okay, so this is how the properties can be arranged. And the last one, it can follow the existence of multiplicative identity. Existence of multiplicative identity, that means if you multiply any matrix with I means identity matrix or unit matrix, you can say the answer will be the same matrix only, just similar to number, means 2 with 1 is equals to 2 na, always. So similar way, matrix with identity matrix always gives us same matrix, always gives us the same matrix. Okay, so this is the overall property of the matrices. Now I can so you can understand, this is the concept. Okay, how multiplication can be done, how multiplication can be done. Now I am showing an example. I am giving a problem first of all. Okay, suppose let A is a matrix is given as 2 0 1 2 1 3 2 1 3 and 1 minus 1 0 1 minus 1 0. Suppose A is a matrix given. Okay, you have to solve A square minus 5A plus 6I is equals to how much? That is the question. Okay, is equals to how much? That is the question. So A square, if you want to make A square means is nothing but A into A. Okay, A is already there, 2 0 1 2 1 3 1 minus 1 0. This is A. Another A means write down again 2 1 3 1 minus 1 0. So this is A into A. If you do multiplication, please remember it is also 3 cross 3 matrix. It is also 3 cross 3 matrix. So multiplication can be possible because number of column in first matrix and number of column in the second matrix are same. So multiplication can be possible. Okay, now you can see here 2 into 2 means how to multiply 7 formation. This into this will be the first digit, this into this will be the second, this into last one is the third, in this way. So 2 into 2 4 plus 2 into 0 is 0 plus 1 into 1, so 4 plus 1 is 5. I am doing directly. So now the first digit already calculated, the second digit means this point. I have to calculate this with this. First row and second column. First row means 2 into 0 is 0, 1 into 0 is 0, 1 into minus 1 is minus 1. So this will be minus 1, second one is minus 1, and the third one means first row and third column. First row, third column. So 2 into 1 is 2, 3 into 0 is 0, 1 into 1 is 0. So 2 into 1 is 2. So 2 is the answer. Okay. Now you have to make this point. So the second row and first column will make this point. Second row and first column means 2 2s are 4, 2 1 2 3 1 3. You have to add all the numbers. 2 2 4 plus 2 1 2 means 4 plus 2 6 plus 3 1 3 6 plus 3 9. So this is 9 is coming. Okay, in this way. So next is second row and second column will make this point. 2 0 2 0 1 1 1 and 2 0 0. This is this and minus 3. So 1 minus 3 is minus 2. Okay, next this row and last column. So 2 1 2 3 1 3 and this is 0. So 2 1 2 and 3 1 3, it is 5. 2 plus 3 is 5. Next last row, third row and first column will this point. Third row means 1 into 2 2 minus 2 0 and 0. So this will be 0. Next 1 0 0, this is minus 1, this is 0. So this will be minus 1 1 1 1 and minus 3 and this is 0. So minus 3 plus 1 is minus 2. So this is A square value. Please remember how to find out. You can understand better. A square is equals to A into A, that is in this way you have to form, means 7 formation. 7 the first, this into this is the second, and this into last is the third, in this way. Okay, and this into this is the this point, this into this point, this into last is this point. In this way you have to find out. Okay, now next 5A minus 5A, 5 into A, 5 into A. 5A means just multiply with A. So 5 to the 10, 5 0 0 5, 5 to 10 5 15, 5 minus 5 0. So this is 5A. Okay, so A square done, 5A done. Now 6I means, please remember 6 into I means identity matrix. Acha, here all the matrix are 3 cross 3. It is also 3 cross 3. So you have to take I also 3 cross 3 means 6 into 1 0 0 0 1 0 0 0 1. This is way. So 6 0 0 0 6 0. Okay, and 0 0 6. This is 6I. Okay, so 3 matrix already has been found. a square found, 5a found, 6i found. Now arrange in this way, a square minus 5a plus 6i. Okay, you have to solve in this way. Now I am rubbing only, I am writing the matrix. Okay, please remember this is the a square. Now a square minus 5a plus 6i. A square is this matrix, 5 minus 1 2 9 minus 2 5 0 minus 1 minus 2. This is a square. Okay, now minus 5a means all the sign will minus done. Now 5a is 10 0 10 0 5 10 5 15 5 minus 5 0. So this is 5a. Okay, so 5a also done. I am rubbing it, 5a, and a square also I am rubbing. So a square minus 5a already done. Now plus 6i. 6i means 600 060 and 006. Okay, now solve it. 5 minus 10 is minus 5, minus 1 minus 0 is minus 1, 2 minus 5 is minus 3, 9 minus 10 is minus 1, minus 2 minus 5 is minus 7, 5 minus 15 is minus 10. 0 minus 5 is minus 5, minus 1 minus 5 is 4 and minus 2. Okay, so this my subtraction done. Plus 600 060 and 006. Okay, so answer will be, I am writing directly, minus 5 plus 6 it is 1, minus 1 plus 0 that is minus 1, minus 3 plus 0 it is minus 3, minus 1 plus 0 it is minus 1, minus 7 plus 6 that is minus 1, minus 10 plus 0 it is minus 10, minus 5 plus 0 minus 5 4, and the last one is minus 2 plus 6 that is 4. So this is the ultimate answer of this first equation. So whenever somebody will ask you to solve this kind of problem, this is how you have to solve. A square then 5a means 3 individually you have to form, then you have to do it. How to multiply a cube? Whenever a cube they will ask, first a cube means, please remember, a cube, if you want to find out, first calculate a square. Okay, if you calculate a square, then after that a into a square is nothing but a cube. So a cube will be equals to, okay, so a cube equals to a into a square in this way. AB and BA, one thing please remember, AB and BA means distributive property are doesn't obey in case of multiplication, means AB not equals to BA. Okay, but in case of diagonal matrix it will follow. Please, diagonal matrix with same order means, suppose 2 0 1 so 2 0 0 5, this is a diagonal matrix having 2 cross 2, this is suppose A. Okay, this is suppose A, and the another matrix is B, it is 3 0 and 0 1, it is also same order, just see same order, and both are diagonal matrix. In that case AB, if you multiply AB and if you multiply BA, that will be same. This is the only condition where AB and BA will be same. When there will be a diagonal matrix of same order, then only it is possible. So this is all about matrix multiplication.